Let's go over your work from part one. Okay, the first thing we're always going to do, because we want to develop this habit, is we're going to represent the argument symbolically by assigning terms, individual letters to represent them. And this is going to reduce the likelihood that we make errors, and it's just going to make our work a whole lot easier. So I chose the terms N, C, and O for this argument. You don't have to have those exact terms. You can have whatever terms you want. You just want to make sure that your final rendition of an argument is an argument with the form I in figure 4. Now we can go on to identify our distributed terms, and that's where we're going to run into a bit of a problem, because this entire argument is comprised of I statements, and I statements don't distribute anything. So we don't have any distributed terms, which means right off the bat we're going to run into a problem with rule number 1, because rule number 1 says your middle term, in this case C, it has to be distributed at least once, and it's not distributed in either premise. Okay, so this argument is invalid because of an undistributed middle fallacy. Our Venn diagram reflects this because we have X's on the lines separating areas 2 and 3 and areas 3 and 4, because when we went to mark the premise statements, we saw that there was 2 possible areas where those premise statements could have an X, but we didn't know which of those 2 areas to put the X in. And when that occurs, we put the X on that line separating the 2 potential areas. And anytime we see an X on a line, that is going to be an invalid argument. For number 2, I chose the terms I, P, and C, rendering an argument with this form, EAE, figure 2. Then we can mark all of our distributed terms, and we've got a mess of them here. Rule number 2 says rule number 1 says your middle term has to be distributed at least once, and P is our middle term, and it's distributed right here in the first premise. Rule number 2 says if you got anything distributed in the conclusion, and we do, they better also be distributed in premises, and they are. We don't have 2 negative premises, so rule number 3 doesn't apply, and we do have a negative premise, but we also have a negative conclusion, so rule number 4 is complied with. And rule number 5 is not relevant because we don't have 2 universals and a particular conclusion. That seems to indicate that this argument is valid. Does the Venn diagram indicate so? Yeah, it does, because look at our C circle. After marking the 2 premises, area 2 is the only area where any C can be. And any C that are in area 2 are outside the I circle. And that's exactly what the conclusion claims. So this argument is valid from both the Aristotelian and Boolean standpoints. Argument number 3 is this. I chose E, C, and S to represent my terms. We've marked all of our distributed terms. And we can see that E is our middle term, and rule number 1 says the middle term has to be distributed at least once. It's distributed in the first premise, so good for that. C is distributed in the conclusion, and it's also distributed in the first premise, so we can see there that we comply with rule number 2. Rule number 3 says we can't have 2 negative premises, and we don't. And rule number 4 says if you've got a negative premise, which we do, you better also have a negative conclusion, which we do. That brings us to rule number 5, and rule number 5 says you can't, from the Boolean standpoint, you can't have 2 universal premises and a particular conclusion, and that's exactly what we have here. And so that would seem to indicate that this argument is invalid from the Boolean standpoint, right? And you can see this in the Venn diagram. We don't have an X here in area 2 that would reflect the conclusion statement. And the fact that we don't have an X there after marking both premises is, again, validation that we're evaluating this argument correctly. It's invalid from the Boolean standpoint. However, because it didn't violate any of the first 4 rules, this argument is conditionally valid from the Aristotelian standpoint. It just depends on whether or not the critical term refers to an existing thing. So we have a conditionally valid argument from the Aristotelian standpoint, and the condition that has to be met is the critical term has to refer to an actually existing thing. What's the critical term here? The critical term is the term that's superfluously distributed. E is distributed 1 time, and it's distributed once in order to adhere to rule number 2. C is distributed in the conclusion and the premise in order to adhere to rule number 2. And S is hanging out here distributed in premise number 2, but doesn't have to be. It's not the middle term, and it's not distributed in the conclusion. So S is our term that's superfluously that's easy to say. Superfluously distributed. S has to refer to an actually existing thing. Spotted owls still exist. So this argument has met the condition for validity from the Aristotelian standpoint. You can see this also reflected in our Venn diagram, where we have area 2 as the only area left where any S's could exist. So we get to mark an X with a circle around it right there. That circle says, okay, there's something here as long as this thing exists in reality. Okay, number 4. CM and I are my terms. We've marked our distributed distributed terms. C is our middle term. It's distributed there in the second premise. M is distributed in the conclusion and in the first premise, so we're good there. But we have a problem. We have an O statement and an E statement for premises, and those are both negative. And rule number 3 says you can't have two negative premises, and that's exactly what we have here. So we violated the rule of exclusive premises. Rule number 3 in this argument is invalid, and we can see that reflected in the Venn diagram when we mark no C or I, and then some C are not M. We don't see that some I are M. Maybe there's some I here in area M, some I are not M. Maybe an X will someday be put in area 5 once we get more premises, but right now we don't know if there's anything there or not. Okay, finally, number 5. We want to have an argument that's in the form of AAI figure 3, and we mark our distributed terms as such. We see that T is our middle term, and it's distributed actually both in both premises. So adheres to rule number 1. Rule number 2 says you got anything distributed in the conclusion, has to be distributed in a premise, but nothing's distributed, so that doesn't apply. Rule number 2 doesn't apply. Rule number 3 says you can't have two negative premises, and we don't. Rule number 4 says you got to have negative premise if you have a negative conclusion and vice versa, but we don't have either of those things. But we hit a roadblock with rule number 5 because we have two universal premises and a particular conclusion. And from the Boolean standpoint, that is an existential fallacy. And this argument is invalid. And we can see that reflected in the Venn diagram. When we mark all T or H and all T or E, we do not see the conclusion statement, some E or H. However, because this has not violated any of the first four rules, this argument is conditionally valid from the Aristotelian standpoint. And we get to mark a circled X in area 3 because it's the only area where any T's can be after we've shaded the premises. So if they're all there, there's at least one there. And the question is, does T exist? Because that's our superfluously distributed term, right? We can see that T is the middle term. It's distributed in both premises, even though it only needs to be distributed once to comply with rule number 1. So the question is, do transparent metals exist? And the answer has actually changed over the years. The answer is yes, they do. They are a very recent invention that are used in cell phones. So the critical term refers to something that actually exists, even though 8 years ago when I was using the same example, that transparent metal didn't exist, and the argument committed the existential fallacy from both standpoints. But now it commits the existential fallacy from the Boolean standpoint only, and it meets the condition for validity from the Aristotelian standpoint.